Okay. Cool. Well, thanks everyone for joining. Today's the 23rd. We're having our cluster add-ons agenda, and we have a few items. Is anyone new to the meeting that wants to bring up any topics or just introduce yourself?
Hi, this is Kong. I'm new to this Zoom and just want to look at what you're doing here. Thank you.
Hey Kong, thanks for joining us. We look forward to hearing your input. And then, yeah, so as far as action from last meeting, I'm honestly a little bit out of the loop right now. Did we take down any action items at the moment? We had work going on with kube proxy, and then that was June 9th. Lubomir, you had the next item.
Hello, this is a bit of a meta topic. I'm sorry about that, but we discussed that the potential integration of the core DNS operator into kubeadm cluster API last week in the kubeadm office hours. Sandeep did a little presentation of the current state of the operator, and then we started discussing the overall potential problem of how are we going to manage the life cycle of the operator once it's installed. So we didn't have a good response to that. I started doing some research, but I didn't end up with anything concrete as in terms of ideas. I also don't see Sandeep on the call today, but I just wanted to get the feedback from this group, like how, once we have this CRD present in the cluster, the controller is running, how are we going to upgrade the version of the controller, the CRD, and also instances of the custom resource? Like we don't have a pattern, to my understanding, for that yet, defined in the SIG for the tools. And I wanted to get feedback from this group.
Okay, that's interesting. So CRDs have version mechanisms, but there aren't a lot of, like a wide number of projects that have started to adopt them. And then we've seen people do other things like move to different namespaces for upgrades. And then mostly the onus has been on the user to actually upgrade the instance of the CRD. But if a tool wants to use that API, that's an interesting question.
So I think sorry, I saw Justin had his hand raised. I didn't mean to jump in there. Go ahead, Justin.
No, go for it. Go on.
All right. So my question was, you know, I think the issue more comes around how do we manage the lifecycle management of the operator itself? You know, we don't want to put that logic directly into kubeadm because then we have the same problem that we have today with updating core DNS itself. It's just now we're doing that with the core DNS operator, and we'd have to do it for any additional add-on operators as well.
I think the main idea, the value add that the core DNS operator brings is that you have this declarative version thing that you can put into the cluster. The code knows how to handle the operation of the application. And so you get out of the business of having to do core DNS specific things, the application specific things. Those don't have to live in kubeadm anymore. But just updating the manifests or updating the package of manifests, like say if it's from a customized directory, is a much easier problem to solve, and it's something that we have already done inside of kubeadm. So I don't know if it is the same that, it's not the same problem. But it is a question that we should have a concrete answer for, which is like, what is the strategy of updating the operator manifest so that it can do its job and be maintained separately from kubeadm?
Yeah, and I think what you said is right, in that the operators are supposed to be easier to update. Like those should always be a kubectl apply, so that there is an advantage there. I think there's another advantage, which is, at least in theory, a particular version of the operator should apply to more versions of core DNS. So if it's a patch release of core DNS, for example, you wouldn't expect that you would have to update the operator. We haven't defined a way that the operator can say, I don't support that version yet, nor a way that the controlling tool, kubeadm or whatever it may be, can say, oh, I need to update the operator because it is like you've asked to go to a core DNS version that is beyond the range. I think a valid update strategy should generally be to always use the latest version of the operator, but that may conflict with tooling's strategies around repeatability and that sort of thing. So we do need to define the way an operator can understand itself, the range of versions it supports, and can also expose that to driving tooling so that the driving tooling can make can help the user do the right thing. But the user experience should be that if you do a Kubernetes side update of core DNS, for example, to a version that is not supported by the operator should know that the version is not supported and should refuse to upgrade to that version. The expectation being that either you'll notice that the core DNS version needs to be updated, or that the update of the core DNS operator is actually coming anyway, because kubeadm is actually doing an upgrade of both, and they just happen to land in the wrong order type thing.
So I think there's another challenge here that we're glossing over a little bit too. And that is, at the end of the day, we want core DNS running with some type of configuration. Right now, we're modifying that directly through the core file that we're creating and injecting in as a config map, I believe. With the operator model, we're trading that out for, an instantiation of the CRD that the operator is going to define for its configuration. And we're going to have to manage, how do we interact with that from kubeadm as well, depending on the version of the operator that's installed, which is a similar challenge to what we're dealing with a little bit today with, migrating the core file. So we need to make sure we're not trading, core file management for complexity around how do we interact with the CRD that's driving the operator.
That's a really interesting point. I'm not fully understanding the problem. Am I understanding you, Jason, that like basically kubeadm has things that it wants to put in the core file? Like, it wants to help make things easier for users. And then you want to be able to maintain that decision across upgrades of core DNS when kubeadm is used to upgrade a cluster.
Correct. It's similar to how we're, managing that core file today.
And the schema of the core file can change, which is problematic.
Right. And the same thing's going to happen if we're talking about CRDs for driving the configuration through the operator as well. There's going to be some benefit in that, we'll be able to take advantage of, the API machinery tooling around CRD conversion webhooks to do some of the stuff so that we don't necessarily have to worry about providing an older version and having that work with a newer version of the operator, as long as whatever CRD we're putting in is supported through the conversion webhooks. But we still have potential issues with, like additive API changes or new functionality that's being exposed, as part of the operator, and tying into those configurations and knowing, potentially when they're available versus when they're not. It depends on how much we want to fully decouple the lifecycle operations, I suppose.
I think some work can be done here to use the features of the core file to break out some of the configuration. When I have configured clusters, I've overwritten the kubedm config to reference other config maps, and basically you can create like a core file.d directory and have other core files be included in your primary one. That's one technique for allowing the user to have the power of extending the configuration without actually having to mutate the thing, so that the state that you're trying to preserve becomes less important. And I think what we have done in the CRD is provide a core file template so that the CRD isn't wrapping every bit of the core file. The user or the person who provides the custom resource instance of core DNS still has full control of a field that defaults. So that I don't see that there are any regressions from moving to the CRD. And then when you talk about maintaining the custom resource instance, as you know, the CRD potentially changes, there is the conversion webhooks. I suppose if you were to move to something that was radically different than providing a core file template or list of them, then that would have to be, that could potentially be a different upgrade. Does that address some of those concerns? Do you see where I'm coming from?
Yeah, I'm still wondering, like, looking at the consumption side, it seems like we're going to have to, know quite a bit about the various operators and maybe the compatibility matrix with the version of Kubernetes that we're wanting to install with that operator to manage this. I haven't heard anything yet that would indicate that the Addons project is trying to kind of solve that part of the problem.
The compatibility of an operator with a particular Kubernetes version. I mean, the way that I envisioned that this was just going to work, and other people might be on the same page or not, was just that kubedm kind of decided to own two add-ons from the beginning, being kubeproxy and core DNS. CNI was not part of that scope. So moving forward, if you want to maintain some kind of backwards support for kubeproxy and core DNS, then kubedm could continue to be concerned with the details of hopefully using a better interface of managing kubeproxy and core DNS. And then that the same mechanism by which it does that, right, could be then extended so that you could use kubedm as a user with your own knowledge of add-on compatibility, right, with your own freedom to choose what CNI vendor you go with, what pre-configured R backend service accounts and pod security policies you want to deploy. Maybe we could also consider that now, right? And break that out. So
I'm also thinking a little bit beyond just like kubeadm here as well, because if you look at like how we handle the lifecycle management of a cluster and cluster API, we rely heavily on kubeadm for the initial bootstrapping and the joining workflow. But when we do the upgrade, we don't actually trigger like the kubeadm upgrade workflow. So if part of upgrade would mean that kubeadm has to, update the version of, say, the core DNS operator and the kubeproxy operator or whatever add-on operators it's working with, we would have to replicate that same type of behavior also in cluster API as well. And I'm trying to figure out which kind of pieces we have of this like lifecycle management of these, what we're calling add-on operators, can be reusable across projects versus what will need to be kind of
and
across projects.
Perhaps we haven't done a good job of communicating that the mechanism being like an add-on installation library could be one of the ways that we could reduce that shared burden. And so that was what we had proposed the mechanism for Kubernetes would be, right? Is like this library that lives inside of Kubernetes SIGs that just has a simple API and does a couple applies. And that library would be easily vendorable and cheaply vendorable into other projects. As an alternative, you could just exec the Kubernetes phase without actually using the upgrade portion of the workflow.
So one of the one potential issue that I see there is that it seems like with the library approach, at least, you're lockstepped with having to keep up and release updates to update that library. For example, right now we have decoupling between kubeadm with cluster API to where as long as kubeadm accepts the version of the config that we're generating, you know, there's no additional kind of maintenance work to support the newer versions. And we've been trying to avoid kind of, you know, having to encode some of that information if at all possible.
Yeah, so using the library, I mean, that API would probably not change in versions much unless we continue to extend the add-on mechanism. But it's API driven, right? So just because some add-ons get updated doesn't mean that you have to update your version of the library.
Oh, okay. So there's some type of...
Yeah, we created a component config that's like a add-on installation list. And yeah, so that basically, you know, like how would you describe to somebody that there's a collection of kubectl applies, you know, of bundles of things. And the first stab that we took at it was, well, instead of having a bash script and depending on kubectl, you know, we could create an API that just has a list of the required information and support customized HTTP and stuff.
There was a particular problem, at least from my side. I think Fabrizio can add more comments to this particular implementation, but for me particularly, one problem was that there was no way to pipe the image requirements from the library to the consumer of the library. So if you're installing CoreDNS, there's no way to get the version and the image repository or set a custom image and custom image repository to the add-on installation. And I thought that this is a major requirement for a lot of people.
This question was addressed. We ended up not implementing the patch functionality, just I think from lack of effort. But the intention was that that would be doable via patch.
So the idea was to, on each installation of add-ons, users can patch what
their own image,
what they want to install in terms of images, configuration, and everything.
Mm-hmm. And on top of that, I mean, the user can pass their own config, right? So like if they want their own manifest completely, then they have that option as well. Because it's no longer like part of the code base that those manifests are generated. They come from a place that's versioned and forkable. So somebody could put that into their own private, you know, GitHub Enterprise instance. Somebody could put it on an HTTPS server. They could use a local file for a customized patch or provide an inline patch. I think is the imagined user experience there. And I mean, I guess if you were KubeADM and you wanted to build something that had like an image override collection, that sounds like a weird feature, but you could, and then just patch your inline config.
But at the end of the day, the library was installing CRDs, operators, and like who was going to manage the lifecycle of those?
The library doesn't install any CRDs, and it doesn't prescribe any operators. You can use it with plain manifests. The component config API is built into the library, so it doesn't depend on an API server.
True, but the goal of this component config that the library manages is to install CRDs and operators.
It is a capability,
Yes.
but we, as the add-ons working group, are not trying to tell somebody how they should install their add-ons. We have some good recommendations and talked a lot about it. There are definitely benefits, but also, come with there's overhead. If just using a CRD requires another, special set of knowledge and maintenance. But yeah, I think using a core DNS operator does give you the benefit of not having to manage a core DNS config upgrade in your code. Naturally, if you want to move that compute like into the cluster and depend on a different component is going to want its own methods of tracking state.
Yeah, which is a problem we are trying to fix. It's a gap. Justin, I saw that you want to implement the core DNS operator on COPS. Do you have plans? How are you going to manage the CRD upgrades and images?
Yes, so I did indeed send a PR, and we got some good feedback. It's around slightly different topics, I'd say. COPS is going to, well, by default, COPS will manage the life cycle of the operators as it does today, so tied to the Kubernetes version. The Kubernetes version will imply a set of operator versions and also a set of CRDs, the versions of the CRDs. It will also, I say by default, because we'll have some way to pick up that, like we're basically adding the ability to add other objects to your cluster, and we'll pick up the idea that some other objects represent an operator. So if we recognize via a sort of well-known label, because we can define a well-known label or something like that, because it's a limited subset of things we are building into COPS. If we see that you have one, we will turn off our default on the operator side. So that's how you can override them. And similarly, the same thing on the instance of the CRD, on the CR. We will auto-generate one for you if you don't override it. If you override it, we will accept that. If you start overriding, it's pretty much on you, right? Like it's the same story we have today with like, we have the ability to set any of the mapped flags we have. So you can set a kube API server flag, but it's the rules are if you set a flag, we don't make compatibility guarantees. Whereas if you use the like higher level abstractions, we are able to like guarantee compatibility because we will map that to the correct flags, even if those flags shift like the grains of sand through an hourglass that is the Kubernetes versions. So there may be other problems, but we have other problems that we've identified, which are that it sounded a bit like what you were saying around images. There are people that primarily for security reasons, more than for the overhead, want to keep the current behavior where effectively there's no dynamic replacement of like bringing in a different version of an image. So in other words, they wouldn't want to change the version of the core DNS CR, the instance of the CRD, and have it update. And so that basically, and they would prefer to have to not have the core DNS operator able to like have the large RBAC permissions that RBAC currently entails. So this is basically pointing to the idea of client-side expansion, and we're trying to understand how to allow both client-side operation and server-side operation in the same, with the same operators. At root, the problem is that we'd probably have to execute Docker locally. We'd have to execute that operator in some weird mode, like with some flag, like a one-shot mode, and we have to figure out whether that's okay or not. And we'd also have to plumb in like all of that through to like do a sort of client-side expansion mode. But at root, we have to decide whether that's even plausible as something we want to support. So that's the update from Copsland, I guess. And I don't know how that compares to what you saw on kubeadm or on your side.
Yeah, I was like pushing for adding this as soon as possible, but we raised too many questions in the meeting last time. I guess if Sandeep releases V1 Alpha 2 of the CRD for the operator for one reason or another, like how are you planning to manage this in COPS? Do you plan to introduce a conversion webhook? Like how is the conversion going to happen?
Yeah, I mean, if there is a V1 Alpha 2 and a V1 Alpha 1, well, let's suppose there's a V1 and a V2 because alphas are trickier, right? Let's suppose there's a V1 and a V2, then yes, we would have to install the conversion webhook, and we would probably with a particular Kubernetes version, as of a particular Kubernetes version, we would start installing the newer version of the core DNS operator that supported both V1 and V2. We would install the webhook. We would likely default at some point to the version, to auto-generate the version 2 CRD. But in theory, if the operator should support both V1 and V2 instances or V1 and V2 declarations, and it shouldn't much matter. It's just that there will be additional features that are only available in V2 and therefore are only available as of a certain COPS version. The way we actually do releases is we tie them to the Kubernetes version rather than the COPS version, just so that, yeah, that's just our strategy. But so as of a particular Kubernetes version, you'll be able to start using those features, unless, of course, you replace the manifest and install the core DNS next version manifest, in which case you'll be able to use them whenever you want, but then it's on you, and it's sort of your, you become responsible for like, oh, it turns out core DNS operator V2 doesn't work on Kubernetes 1.17 or whatever it might be, right? Then that's sort of up, hypothetically, then that's up to you.
Yeah, I guess this makes sense. For the kubeadm case in particular, I was getting concerned that kubeadm should not be responsible for the migration of the CRD version. It doesn't feel appropriate.
I think that's correct. I don't think you are responsible for the, I mean, you are not responsible for the migration of the CRD version. You can, if the operator is installed with the webhook, you shouldn't have to migrate.
Sorry for interjecting here. I just want to mention there are a couple of caveats around that whole process. None of them insurmountable. It's just, I'm not sure that the docs spell it out in the best way right now, but conversion webhooks don't convert the underlying stored object in etcd. So if you don't have something that comes around and reads and rewrites the object back at the right version, and you can't query Kubernetes to find out what the stored version is. So if you don't have some process managing that for you, then you can eventually update to a state where you no longer know how to convert what's actually stored in etcd. So it's, yeah, like I said, not insurmountable, but there are some complications.
And I saw a number of tickets in the operator SDK repository, people asking like, what is the best process, being confused. I shared a couple of links, and hopefully these are up to date, but they mentioned the storage version, Kavits, I think, but overall, this is like a complication that it feels like Cluster API has to do it, Kubernetes has to do it, Kops has to do it, and this is where we are getting into the space of multiple tools trying to solve a very complicated problem.
Yeah, I would hope that we can like identify a pattern. Like if we can all like, I don't think we have to agree a pattern, right? We're not going to force everyone to agree a pattern. I think we can identify, I hope we can identify a pattern in that, like, if we can agree that, or if COPS shows that the approach of like a particular Kubernetes version is tied to a core DNS operator, if that works, right, then we can like say, here's a manifest at least, and ideally a library as well, that like a generic library that enables you to say like, for a particular version of Kubernetes, like let's go source that manifest, right? It's sort of like a tested, I don't know, a tested compatibility set, and we can hopefully share that in some way. I agree that we don't want to re-implement the same logic. I don't think we yet, Evan might, but I certainly don't yet understand all the nuances yet enough to like say we're ready to define it. I want to share, I don't feel confident saying, here's how you should do it.
Yeah, and again, this problem, we either implement the migration logic of core DNS in all the tools separately by importing the migration library, or what we have is potentially in the future is everybody has to include a custom conversion logic to quote unquote conversion logic in all the tools until or unless we have some sort of a library that does that, which is, we solve one problem, we introduce another problem, and today I spoke with Fabrizio and others, and basically we are solving one management problem, introducing management complexity. So yeah,
I kind of saw a lot of these things as like should be distributed in package, and if you have breaking changes or topological changes in your manifests, like you should distribute them as a new version of your add-on with the same key. And that the way that the installation library would solve for this naively was to allow users to define what should be pruned as a collection. So it's because like, yeah, if you want to install a webhook, if you want to install a new service account or update RBAC roles to be something different, you can create objects with new names and migrate the app to those. We could even add a key that says whether or not it should be pruned before or after. And if you have that in your installer, I mean, it's pretty sufficient because most of these things should be very declarative. I think we've done a lot. We've created a lot of problems for ourselves by trying to reuse the names of objects that are not the same.
Yeah, this is it's a very meta topic. I don't think we can get a resolution in this meeting in particular. Just we have to think about something.
What would be a example of that problem that we could provide a technical solution for to demonstrate that there is an approach?
The testing the scenario is somebody installing the core DNS operator today. I believe the version is v1 alpha 1 of the custom resource. So a new version is introduced after request by a lot of people to have some new fields in the schema.
Mm-hmm.
Basically, you end up with users wanting to use a new feature, which means that you have to upconvert them to the new version. And you don't, you have to create documentation for that, or you have to implement the logic in your tool.
Yeah, I think it's pretty fair to expect that a user can just decide to use the new API. So implementing conversion logic for those things directly in the tool, at least it's not necessary for every operator. If you'd like to add some UX, and take on that maintenance inside of your tool, you can build a subsection of it that helps them migrate their config. But yeah,
specifically on that exact point, like we talked, I mentioned that we might want some extension to KubeBuilder or whatever it is that would do client-side expansion of an add-on. One could imagine a similar expansion of KubeBuilder that would like expose the web hooks in a way that can be used client-side, if that's useful. I don't know. I'm still not entirely clear whether you need it. I guess you do because you want to add well, that's I guess you do, and then so we could maybe do that. I don't yet know of a way that doesn't involve running Docker, so I don't know if in the general case, I don't know if that would be acceptable to like suppose we added that to KubeBuilder or to KubeBuilder generated controllers or whatever you want to call them. Would that be acceptable? Would that be a good thing for you? Would kube-adm start using that for their version conversion?
Yeah, I mean, in projects in general, not kube-adm only. If there is a way to, harmlessly, without user interaction, convert this stuff, it feels to me like either core Kubernetes has a missing feature somewhere related to CRD migration, or KubeBuilder has to work around this whole problem, maybe.
Yeah, I don't fully understand the use case for. Sorry, I just want to say I don't fully understand the use case for why you want to client-side migrate their CRD for them type thing, I guess.
Because of the client side, they might want to set this particular field to a certain value, this new field.
Yeah, so I see. So they want a new field. They have a v1 alpha 1. It's the new field is in v1 alpha 2, and we currently essentially what we said with like every migration so far is like do it yourself. Like you have to upgrade from extensions v1 beta 1 to apps v1 deployment or whatever it is, and that's a human operated client-side conversion logic. I see what you're saying. That makes sense.
Yeah, and when somebody wants to do that, say across 100 clusters, which is realistic for some deployments, then in that case, you're going to want to do a tool-based migration of some sort with some human validation. And yeah, I agree with you, Lubomir, that the problem of managing config migrations across API changes is an underserved use case inside of Kubernetes. This is the kind of problem that keeps me up at night because the machinery that we have built is very married to Go and comes with a lot of Go's limitations. It is very difficult with our current API machinery to perform a config migration that actually is useful for somebody, if at all. But there is work in the server-side apply that introduces new API machinery and a field manager that could potentially be useful outside of the API server to build client-side tools that could help people do tool-assisted config migrations. I don't think that it is appropriate for a tool to take full ownership of a config migration for a user without any user intervention. There always needs to be an escape hatch for a user to be able to either mutate or provide their own config, because a tool will not do it properly for every use case. And people might just decide, hey, I don't want to actually use that old field that I was using, even though there was an equivalent. I want to change the strategy, or I want to provide this value, or I don't like the new default. Those kinds of things, you can't take that away from the user. But yeah, managing the config is a tough problem. I think the only complete solution right now is to allow people to provide their own upgrades. That's the only thing that like exists completely. Everything else is substandard. If I provide a config file that is a v1 alpha 1 API and it has 5 user specified fields, but the API has 34 fields and v1 alpha 2 has 50, it's not useful to a user. It's only useful to a machine to take that user specification and actually convert it to v1 alpha 2. But what the user ends up with on the other side is a file with 50 fields, 45 of which they did not specify. And that's a huge problem, like with a tool-assisted migration. And, so
I mean, yeah, we can have better tools for that. You know, the up
yes, we
conversion.
can.
The up conversion doesn't necessarily have to include all those 50 fields with the default.
Yes, but we need to use the newer machinery in ways that it's not currently being used, because
Yeah,
our old machinery, the stuff that we build everything with, cannot do that.
Yeah, I understand what you're saying. I'm just talking about the hypothetical different
Yes.
universe where
I think we can.
different API machinery. There's also something that we can borrow as an idea from Git workflows. So Git operations locally in a terminal are fairly low level. People have to, for instance, rearrange their patches. So Git gives them an option to have an interactive overview of the list of patches, you know, with git rebase -e. So the same way, when you have a folder with hundreds of manifests, we can have tooling that can give you interactive diff of what changes in each file. So this is the same like low-level operation that people have to perform every day anyhow. So this is going to reach people in a comforting level. Problem is that of course we don't have agreement that we want these tools to exist in the first place, like conversion tools, like client-side conversions. The problem starts there. I'm sorry, we dragged this topic also tangentially a little. If you have anything on the agenda, please continue.
The next bit was just about, well, Justin was the only person who put something specific on the agenda. Justin, did you want to touch on that? We still have 10 minutes or 12 minutes. So.
Yeah, I believe we sort of talked about it in the context of that previous discussion. I don't know if there are any other topics that anyone wants to bring up around that. Otherwise, we can open it for general, right?
So this is a pull request to COPS that contains an integration of the core DNS operator into COPS.
Exactly so. So if you
hidden behind a feature
use
flag.
this, hidden behind a feature flag, if you use this and you set the feature flag, then it will and you are using core DNS, which isn't currently the default in COPS. It will be in 119, I think. Then it will no longer use the built-in manifest. Instead, it will install a manifest for the core DNS operator, which it sources currently over HTTPS. And it will create a CRD or an instance of the CRD, and the operator will then install core DNS. So it is using the core DNS operator. It doesn't yet tackle many of the hard problems like version upgrades, for example, and it doesn't tackle, it's actually, well, it's getting there. We can probably use our existing mechanisms for upgrading the operator because we do specify the version of that. But it doesn't tackle like client-side expansion or anything like that.
And this is in a channels operators directory. So, yeah, so there's already channels inside of COPS.
Yeah, so channels is our things that we fetch over the internet that allow for dynamic updating. So it tells you like the newest recommended version of Kubernetes is this version, for example. You can always override it, but if you don't specify, then it's like, you know, this is the current stable version, for example. And in this directory, we are adding the ability to put manifests there, so we can, instead of baking them into the binary, we can go and fetch a particular version of that manifest. And currently that version is hard-coded in COPS. We could imagine putting that version into the channels file, which is itself a YAML file, so that we could say that if you don't specify a version, the stable version of the core DNS operator for this version of Kubernetes is this version. Like, I think I called it 010 or something, or 001. And so I think this goes back to the previous point about kubeadm, which is, you know, we don't necessarily, if kubeadm has a similar mechanism, we don't necessarily need to update, in our case, the CUPS binary, but like the kubeadm binary to update the operator, as long as it is just a version, as long as it's just a manifest update.
Yes. Yeah. That the mechanism for applying those things is simple, and that it is driven by configuration that is not only open to the maintainers, but also open to the users.
Yes, the user is very welcome to like maintain their own channels file. They are able to specify it like very easily. We don't, and to be clear, we don't yet have that mechanism where we fetch the version of the core DNS operator from the manifest, the stable channel, as it were. We can add that if like down the road. But you know, this is a first pass and gathering feedback. And I think there was like the two items of discussion were the privileges that the core DNS operator gets are very powerful, and the notion that that the version of images deployed might change is problematic for people that do things like mirror their images, for example. So they would want to have it all be on the COPS client side in the CLI rather than being more dynamic.
I see. So talking about the user needs, right, is like some of the same ones that were brought up, right, with kubeadm's concerns would be, you know, overriding images, and what else were you saying, Justin? RBAC is very powerful.
Permission. Yeah, the RBAC mechanism, using RBAC is a very blunt hammer, and in this case, it can do a lot of things. It's not clear whether the right answer here is we should build a more precise mechanism than RBAC, right? Which is, or whether we should actually, the people that worry about that would actually probably be better served by client-side expansion anyway. Like, you know, if you want strict, like if you're going to be, if you care about that RBAC permission, maybe you actually care about, you know, from the start, seeing exactly what's going to be applied in your cluster.
Yeah, and this is the point that we've touched on from the very beginning, which is potentially like building one-shot operators and jobs, you know, and having tools install temporary RBAC, a la kind of like a sudo, right? But even if you were to install an operator, right, and then just revoke its RBAC, you could end up with an erroring operator. So that, like, there are ways to kind of achieve that sort of temporary privilege escalation for that kind of user.
For the overwriting images issue, this doesn't help directly, but I did think it's worth mentioning the OpenShift approach to the problem is that there's an API available in clusters that translates into node config for kubelet. So all of your manifests can retain their original references to the original files, so that if you have some provenance over those, they don't change at all. But then the kubelet, when it goes to actually pull and run a pod, it swaps out based on whatever the config is in that API. So I don't think I know of anything in the kube community that does that, but that could be an approach that gets you a lot of the properties that you want.
So the OpenShift's kubelet is modified to do image overrides from an API that's driven inside the cluster.
I mean, it's really Cryo that's doing it, but
Cryo
yes,
is.
yeah.
Okay. Does Cryo get the API from directly on the node?
I believe it queries the Kube API for it and then
Interesting.
reconfigures the node based on it.
CRI querying Kubernetes. Interesting. Cool.
It might be the other way around. It might be something else queries it and then reconfigures the node when it changes. I don't remember.
I'm going to take the time to read this patch. Justin, if you're still here, I know we're toward the end of the meeting. Would you be open toward me trying to figure out where the installation library could fit into that patch and potentially add value in a more generic way than just the...
Absolutely, yeah.
Cool.
I am here. I just I'm on web, so who knows what happens to my video? I don't know if it's working or not. Yes, if you look at that PR, it actually is based on an earlier PR, so it's split a little bit more nicely than it is in the yeah.
Okay, cool. Yeah, if I might try to make some suggestions or draft my own version of your same logic that attempts to use the installation library potentially. And that might help us get to a place where the bit that we were talking about being able to implement with the versions being defined either by the user or, you know, like through a defaulting HTTP fetch or something could be useful.
Awesome, thank you.
I'll probably do that now after this meeting. Great. Well, we've got just 3 minutes left if anyone wanted to pipe in or potentially create a follow-up meeting for any particular ideas here. Certainly the problem of config upgrades is something that we could talk about it on working group component standard maybe next week.
Since we just have a couple minutes left, maybe some clarification on that problem. I'm not sure I followed it to the degree that everyone was discussing it. I guess as an example, the issue here is that the core file is part of the config. And so when you update the operator, you would need to encode some translation between core files. Is that the idea?
The approach in the operator right now is to provide a core file template and that some of the static fields that are provided in the CRD are like available for interpolation. So things like the like cluster IP and stuff like that. But yes, the real more generic problem is just that when CRDs get updated or when a Kube API gets updated, it doesn't even have to be a CRD. It is on the user to get to the new version. And often that is a large burden because there are many objects. So consider like moving all of your deployments from extensions to apps v1. And there are field changes, there are default changes, and a lot of that should be tool assisted. The API server knows how to migrate these objects and produce machine readable equivalents, but that doesn't necessarily mean that it's the user intended equivalent. And it also doesn't produce a commented, you know, user minimally defined like user equivalent like for those objects. So this gets, we have the same problem with the component config APIs that are used in KubeDM and in third-party CRDs where people have to do manual upgrades or do some weird like grepping and sed replace things on their own, and or else you end up with suboptimal migrated configs. And this is largely because of some limitations in our traditional API machinery. There is some new API machinery available that was used for the server-side apply implementation. And that API machinery could be useful in building some better tool-assisted migration workflows for users.
Gotcha. Yeah, I guess
it's kind of a gnarly problem. So
it sounded like most of it is covered by the conversion webhook problem, although it'd be interesting to see what the failure modes are if the conversion webhook can't get you the version you're looking for.
It could probably produce an equivalent config in many cases from a machine readable perspective, but what happens on the next conversion up, right? The things that the user had not specified get the defaults for API number 2. Then when you try to go to API number 3, then you end up with the defaults of the old version. And the user never specified those things, you know? So
it could be an issue with user intent, but like from the API perspective, there's always an object that is conforming to whatever the particular level of the API is.
Mm-hmm.
And that input always results in the consistent output of the config for whatever operands, or in this case, CoreDNS are using it. So I think if you buy into the model and you buy into the machinery, I don't see a huge problem as long as there's a way for a conversion webhook to say, I don't know how to convert this. You have to do it yourself. I mean, in theory, I would think like that operator is the place to encode the knowledge of how to convert between different versions.
Yeah, and a lot of this as well is like that has to happen in the cluster after you're applying objects, and tools want some of this to be client side for dry run features and things like that, because they want to be able to use a new field, you know, and that field is not available in that version of the API. It's particularly problematic when you're trying to upgrade a cluster.
Very familiar with that problem, and I would say that my interactions with folks from API machinery is that they don't really feel you should be doing any sort of off-cluster conversion of anything, really. It should be always up to the API server.
To the API server itself. That's fair.
If that's fair of me to represent a group's opinion, which I may have done inaccurately.
I can see why that would be a common suggestion in general, even if it's not, you know, a wide opinion. Great, cool. But yeah, that's the gist of the problem statement with some of the solutions and limitations around that issue. So, yeah. Cool.
Thanks, that was really helpful.
Well, thanks everyone for joining. This meeting will go up in recording on YouTube, and we'll try to continue some discussions in the relevant working groups. And yeah, everyone stay safe out there.
Thank you. Bye-bye.
Thanks, Vladimir.
Thanks. Bye.